This is exercise 6.3, placing a driveway civil cell. In this exercise, we will model a driveway and then place and manipulate the driveway civil cell. So go ahead and open up the RDWYII alignments DGN file located within the Chapter 6 subfolder. Once the file loads, make sure that the default view is active in the lower left corner. Then we can check what files have been referenced for us. We need to make sure that we have the CC corridor and the CC terrain DGNs referenced. And locate the driveway at station 140+00. The horizontal geometry has been created, but now we can create the vertical geometry. Make sure that the existing terrain is active. And go ahead and open up the profile view of the driveway center line. Now open the Profile Intersection Point tool, which is under Open Roads Modeling, Geometry, Vertical, Profile Creation. In the plan view, select the driveway center line, and then we will select a few more lines. Once you have the tool open and the 2D view active, we're going to go ahead and select the center line of the driveway. And we're going to select some lines that intersect this drive. So the first one is the EOPL, then the PSHCGL, then the CR flow line L, then the CR back top L line, then the SW front top L line, and lastly the SW back top left line. And as you're doing that, you should see some pink dots appear in your profile view. Next, we're going to select the Prop VA driveway feature definition, which is under Linear, Profiles, Roadway, Proposed, and turn on the key point snap and connect the points using the Profile Line Between Points tool, which is under Open Roads Modeling, Geometry, Vertical, and Lines. Then from the SW back top L intersection point, we're going to draw 3 more tangent lines. This first tangent will extend the vertical curve outside the limits of the sidewalk. This first line will be 15 feet at a slope of 1.5%. Then from the SW back top L intersection point, we're going to draw 3 more tangent lines. This first tangent extension will keep the vertical curve outside the project limits of the sidewalk. So this first curve will go from this SW back top L point and go for 15 feet at a slope of 1.5%. The second line will go from the end of that point, 0.75 feet, at a slope of 14.95%. And the last line will go for 13.49 feet at a slope of 1.72%. We now need to insert some vertical curves after the back of the sidewalk. So let's go ahead and open up the tool. Parabola Between Elements, which is located under Open Roads Modeling, Geometry, Vertical Curves, and then Profile Curve Between Elements. We can set the trim extend to both. And then remember, per the TDOT driveway entrance manual, the minimum K values for crest and sag vertical curves are 1 and 2 respectively. For this first curve, go ahead and select both lines and set the vertical curve parameter to 2. And with the second curve, we are going to set the vertical curve parameter, or K value, to 1. Then we can complex the vertical geometry elements. And make sure that the new complex vertical profile is set to active. Now let's open up the Road2 CC corridor DGN file located within the Chapter 6 subfolder. Once the file loads, make sure that the multimodal views is active in the lower left corner, and let's be sure that we have the correct references. For this file, we need the CC alignments DGN reference, the CC intersection corridor, and the CC terrain DGN files reference. Also note you should see your driveway alignments in the reference geometry file. Also, for an actual project, the driveway civil cells should be in a separate file to keep the file size manageable. Civil cells do contain a lot of data and quite often slow files down. Next, we will place the applicable civil cell along the alignment. Go ahead and open up the Place Civil Cell tool. It's located under Open Roads Modeling, Model Detailing, and Civil Cells. Within the Place Civil Cell dialog box, click the 3 dots to open the Civil Cell folder, and then give the software a minute to open. Then select the T.dr residential curb and gutter civil cell under the entrances_t.dgnlib and click OK. Then in the 2D view, we're going to follow the prompts on the screen. Locate the driveway centerline at station 140+00. First line we're going to select is the CR flow line, and then the CR back top, then the SW front top, then the SW back top L, and then the driveway centerline. A 2D preview of the civil cells should now appear. You can switch the previously selected reference line's direction by clicking on the reference lines until the civil cell preview looks correct. So go ahead and right click to advance to the next prompt. And note that in this exercise the civil cell looked correct, but if the civil cell was placed on the other side of the road, the reference lines would need to be reversed. Then select the corridor that will be clipped. For this exercise, it will be the mainline corridor. To confirm the clipping, make sure that the corridor graphics are highlighted. Right-click, then left-click to accept the civil cell placement. And it should now be viewable in both the 2D and 3D views. Note that you should only clip corridors that are in the active file. If the corridor was placed in a different file, you would need to go to that file and then clip the corridor. For this driveway civil cell, the software only models up to the back of the sidewalk. To complete the rest of the driveway model, we will need to place a corridor along the alignment. We will use the orange controlling elements placed in the civil cell to control the edge of the pavement. So go ahead and open the new corridor tool located under Open Roads Modeling, Corridors, Create. And note that there are 2 horizontal alignments to select. DR2, this one is connected to the civil cell and only extends to the back of the sidewalk to the end of the alignment. Example drive, which is the complex horizontal geometry that was created a profile for earlier in the exercise. For this corridor, let's go ahead and select the example drive alignment. Once the alignment is selected, a prompt should appear asking to select the profile of the element. The active profile will be set, so right-click to accept the active profile and then left-click to accept the name example drive. The Create Template Drop should automatically open. If not, open the New Template Drop tool under Open Rows Modeling, Corridors, and Create, and then place a new template drop on the corridor. Select the Drive-Residential-Concrete template, which is under Linear Templates and then Driveways, as the template drop. For this template's beginning and end stations, we're going to start at the back of the sidewalk, which is station 0 plus 35.50, and then extend to the end of the corridor. And then left-click through the prompts. And notice that the mainline corridor is overlapping with the driveway corridor. Open the Add Clipping Reference tool, which is under Open Rows Modeling, Corridors, Miscellaneous, and then Corridor Clipping. Select the mainline corridor and then the driveway corridor as the clipping reference. Right-click to complete the clipping. Next, open the Define Target Aliasing tool located under Open Rows Modeling, Corridors, and then Miscellaneous, and select the driveway corridor. Now we're going to add the corridor-OLDR_OP2 and click Apply. Then add the terrain model -WI4450-02FDTM. This is the existing terrain, and then click Apply. And then we can see that the intersecting corridors have been resolved. We now need to add 2 corridor references to the driveway corridor from the driveway ramp civil cell, which is the area from the flow line to the back of the sidewalk. Open the Add Corridor Reference tool, Open Rows Modeling, Corridors, Miscellaneous, and the corridor reference, and select the driveway corridor. Then select the DREOPL Control 1 line, which is located under the left EOP line of the driveway, and then right-click to accept. Next, we're going to change the width of the DREOPL Control 1 line from -6 to -8 feet by selecting the line. Edit the width in the orange midpoint offset manipulator to revise both ends of the control line. The driveway corridor should now move in conjunction with the width of the driveway civil cell. The easiest way to select this line underneath the line is to right-click on the EOP line and then left-click the dashed line, or you can turn off the levels. Now we need to repeat the last 2 steps, but select the DREOP R Control 1 line, which is under the EOP R line. And we're going to change the width to 8 feet. But this time I'm going to turn off the EOP lines. The corridor now needs to be adjusted to make sure that the driveway cross slopes mirrors the profile grade of the mainline corridor. Go ahead and open up that DREOPL Control 1 profile, and note that this only needs to be done so that the model aligns. The PDF set of plans will not show this level of detail. Within this profile, there will be 2 lines. We have the DR profile EOPL, and this one is the current profile of the driveway, assuming that the cross slopes of the line is 0%. then the variable slope L line, which can be adjusted as a secondary profile of the line if needed. There will also be a pink dot in the profile, which indicates the elevation of the sidewalk back top of the driveway civil cell. Through an iterative process within the variable slope L properties, it has been determined that the slope of the mainline sidewalk at this point is negative 2.22%. So currently the driveway EOP lines do not intersect with the sidewalk back top of the driveway civil cell. We'll need to transition the driveway's EOP profile to line up with the sidewalk back top. Go ahead and select the proposed EOP driveway control feature definition, which is under Linear, Roadway, Model Centric 2D Plan, and then EOP. Then open the Profile by Variable Slope from Elements tool, which is under Open Rows Modeling, Geometry, Vertical, and then Element Profiles. Go ahead and set the style to linear and then select the DR EOP-L Control 1 line in the plan view as the line we want to profile, which is still located under the driveway EOP-L level. And if you haven't done so already, you can go ahead and turn off that Design Model Lines Pavement Edge level to make it easier to select. Then as a reference element, we're going to select the driveway. Be sure to select the example drive center line. And we're going to go ahead and set the start slope to negative 2.22%, the end slope to 0%, the start distance to 0 plus 35.5, and the end distance to 45.5. And then click through the remaining prompts to create this profile. And then notice the new line within the profile view. This line should be transitioning from the pink dot to the driveway profile EOP-L profile line. Now go ahead and select that variable slope L profile line and open the properties. Then within the properties underneath the profile by projecting 3D element slope rule header, we're going to change the start reference distance to station 0 plus 10 and the start and end slopes to 0%. Now we're going to complex the projected line and the variable slope L together to create a new profile for the DR EOP-L Control 1 line. And then we're going to set that profile as active. Then we can close out of our profile and turn that EOP level back on. Design Model Lines Pavement Edge. Now for the slope to place properly, we need to create a point control. Go ahead and open the Create Point Control tool under Open Rows Modeling, Corridor, Edit, and then Edits, and select the driveway corridor, and then we can start filling out the parameters. So in these parameters, we want to lock to start and lock to end. The point that we want to select is EOP-L. The mode we want is vertical. The control type is feature definition. The feature definition we want to select is proposed EOP driveway control. And this is under Linear, Roadway, Model Control 2D Plan, and then EOP. We want the range to be negative 10. Priority to be 1, and then start and stop vertical offsets to be 0. Once you have all this set, go ahead and start left clicking through the prompts. Now the driveway should be flush with the edge of the sidewalk on the left side. And we can see that in the 3D view if we rotate our drive around. So we see that the side here, which is the left side of the driveway, is now flush However, on the right side, it is not flush because we haven't done that yet. So if you wanted to make this side all flush, you would have to repeat those last few steps. But make sure that the right side for the slope of the sidewalk is a positive 2.22%. This concludes exercise 6.3, placing a driveway civil cell.